Hi, everyone. So welcome to the Exam 1 review. Let's first go over some basics regarding an atom and its electron configuration. So as we know, every atom is made up of a nucleus at its center, and around that nucleus we have an electron. The thing is, the electrons don't just occupy random areas in space. They have a specific electron configuration. And there's two things we have to know about them. The first is the principal energy level of the electron. And the second thing is the orbital. The principal energy level is also known as the shell, and that corresponds to the horizontal rows of the periodic table. So let's say we have a periodic table right here. So this first row that hydrogen and helium is at would be the first energy level. The second row where lithium, beryllium, boron, carbon, nitrogen, etc. are at would be the second energy level, and so on. So the further down you go, down the rows, the further away from the nucleus the electrons are, and the higher in energy they are. The valence shell is the outermost shell of an atom. These are the electrons that are the furthest away from the nucleus, and it's the lowest row that you're at when you're reading the periodic table. And it's the electrons in this shell that participate in interactions with other atoms. So it's these electrons that actually take part in chemical reactions. So that's the energy level of an electron. The other thing that we have to know, and maybe the more important thing, is the orbital, the atomic orbital or electron orbital. That's also known as the subshell. And all an orbital is the geometrical region of space that an electron can be found in. So it's just the geometrical shape that an electron creates or is found inside of. And the only two that we have to know are s orbitals that look like spheres and p orbitals that are dumbbell shaped. And for every energy level, you're going to have one s orbital. And for every energy level, you're going to have 3 p orbitals. And these correspond to the vertical columns. So back to our periodic table. So here's our first vertical column. Here's column 1. So that's going to be the s's. Column 2 is also going to have s orbitals. That's why the first two columns in our table are known as the s block. So everything in pink here is the s block. This legend says so right there. We skip over all of this light green. That's the d block elements, and we don't deal with those in organic chemistry. Or all of these in purple, which are the f block. So just ignore all of this stuff right here. And we skip over from the s block to everything in green, which is the p block. So these orbitals over here are going to look like dumbbells. So let's go through a few of these atoms to see what their electron orbitals look like. Here's hydrogen, the simplest of all atoms. It has 1 proton and 1 electron. Its 1 electron is going to be in an s orbital, and it's at the first energy level. There's only 1 electron, so it can only be at that 1 energy level. And because it occupies an s orbital, it's going to create a spherical shape, and this red sphere is what it is. At the center of the red sphere, I wish they had like a black dot in here. That would have been the nucleus. This red sphere is where you can find hydrogen's 1 electron. Let's go to helium right next to it, right next to the hydrogen. Helium is going to have 2 electrons in its 1 and only energy level. It only has 2 electrons. It's in the s orbital, so it too is going to be a sphere, this at the center of which we have the nucleus of the helium atom. And in this red sphere, you're going to have 2 electrons. Hydrogen only had 1 floating around in here. Helium's going to have 2. Let's move on to the next atom, which is going to be lithium. Lithium is going to have, at its first energy level, 2 electrons. It's going to have everything that atoms before it had, plus whatever it has. So it has everything that helium had. So helium had 2 electrons in its first energy level. which is that red circle in the middle. See right there? So those are the first energy level electrons. There's 2 of them floating in there. And then the second energy level, which is further away from the nucleus and higher in energy, because we're at the second row, is going to have 1 electron. So there's going to be 1 electron in this outer blue sphere. And again, both the red and the blue look like spheres because we're still in the S block area. Let's move on to beryllium. Beryllium's going to have everything that lithium had plus whatever it has. So its first energy level, the red, is going to have 2 electrons in it. And the blue energy level is going to have 2 electrons in it. Remember, lithium only had 1. Then we move on to the next atom, which is going to be boron. And we're in the P block now. So I wish they would have shown like the S orbitals here, but here we're only looking at the P orbitals of the P block element. So boron is going to have essentially everything that beryllium had, plus whatever it has. So boron's S orbital is going to be packed with 2 electrons, and then it's 1 p orbital, which you see right here. Remember I said it was dumbbell shaped? So this dumbbell shape has 1 electron inside of it. Let's go on to the next atom, which is carbon. So carbon's going to have 2 electrons. I lost my pointer. There we go. So carbon's going to have 2 electrons from back here, and then it's going to have 2 more electrons in its p orbital. So here they didn't show it, but it's going to have 1 px orbital that would be horizontal, kind of like that, and then 1 vertical one like that, and each of those p orbitals are going to have 1 electron in that. And we're not going to go through every single element. Let's just skip forward to neon, or I guess not. I didn't put neon in, but you get the idea. There's a third p orbital, which would be in the z direction. Remember we said each energy level has only 1 s orbital, only the 1 sphere, but it has 3 p's. So it's going to have a p in the x direction like this. This is a figure 8 in the x direction. Then it's going to have, let me zoom out, and then it's going to have a p in the y direction like that. And then it's going to have another p that's coming out at you, and the other lobe of the p is going further into your computer screen, like going away from you. And so you essentially just fill all of those up as you move from left to right, and you do that for every single row. You're not going to really be tested on any of this. I just wanted to introduce to you the vocabulary, because you're going to keep hearing the words shell and orbital and s and p over and over again. So at least now you know, you have a pretty good idea of what we've been referring to this whole time. The last little bit of vocabulary I wanted you to know is electronegativity. Electronegativity is the tendency of an atom to attract electrons to itself. So the bigger the number, the bigger the electronegativity number, the stronger that atom's electronegativity, the stronger its ability to attract electrons to itself. So if there was an atom that had an electronegativity of 5, as opposed to, let's say, 3, then it would attract electrons very readily and probably be negatively charged. So basically, the bigger the electronegativity number, the more that atom wants to steal an electron or electron density from its neighboring atom. So it becomes more negative and its partner becomes more positive. You, of course, don't have to know the exact numbers. You won't even get a table telling you what the numbers are. All you have to know is this definition. So as long as you understand that definition, you're fine. And you have to know the pattern. And the pattern is just generally as you go from the bottom left of the periodic table up to the top right, the electronegativity becomes stronger. So let's look at the periodic table without the big red arrow, if I were to ask you what's more electronegative, this oxygen or that chlorine, or let's say this fluorine or that boron, who would be more electronegative? So hopefully you said fluorine. So if the fluorine was bonded to the boron, this fluorine atom would be stealing some of boron's valence electrons, at least some of their density. So the boron would become partially positively charged, and the fluorine atoms around it would become partially negatively charged, just because they're more electronegative. So that's the basic vocabulary that you should be familiar with. Just what the words mean and what their significance is.